Hi everyone, today we are talking about graphing linear inequality. So the very first thing we're going to start is the checking an order pair. And that means that checking the order pair is a solution of the equation we are graphing or not a solution. So to do that, the procedure. Now guys, make sure you write down the procedure because I'll be looking for them. You don't put it down, I'm going to start taking points off. So the procedure is to determine whether an order pair is a solution for an inequality. Replace the variables with the corresponding coordinates and see if the resulting inequality is true. That means they equal to each other. If it is, the order pair is a solution. So just pretty much plug it in and see do they equal to each other. So first of all, you need to remember x is the first one and y is the second one, and that's the order pair. And because of that, you just have to plug it in for the next step. And that is going to be y is 7, so 7 is greater than equal to -2 times -4 plus 3, and just simplify them. So 7 greater than or equal to -2 times -4 is positive 8. Negative become positive plus 3. It's 7 greater than or equal to 11. Well, 7 is definitely not bigger than 11, so no. -4 and 7 is not a solution. For y is greater than or equal to -2x plus 3. Okay, that's all you have to do. Go ahead, try number 2 and see do you guys get the same answer. So pause the video right now. Example number 2. Determine whether the given order pairs is a solution for the given inequality. 3x minus 5y less than 6. You still have to use your -1 and -2. -1 is your x. -2 is your y. My number 2 is also an answer no. You got 7 less than 6, and 7 is definitely not less than 6. Okay, going on to the next one. For the next topics we're going to talk about is graphing linear inequality. The procedure is to graph a linear inequality in two variables. That means x and y, or a and b, depends on what the problem they give you. Number 1, graph the related equation, the boundary line. The related equation has an equal sign in place of the inequality symbol. If the inequality symbol is less than equal to or greater than equal to, draw a solid line. If the inequality symbol is less than or greater than, draw a dotted line. That's the first thing, dotted line or solid line. 2, choose an order pair on one side of the boundary line and test this order pair in the inequality. If the order pair satisfies the inequality, shade the region that contains it. If the order pair does not satisfy the inequality, shade the region on the other side of the boundary line. And I will show you some other little things I say to myself to keep everything clear. Make sure you write the pink part down. If you don't, I will take points off. So let's try number 3, how to graph the linear inequality. So the first thing they say in your procedure is, if you take a look, we have a greater than sign. What the procedure tells you to do is pretend you are graphing y equals 3x plus 1. And so you know your m is equal to 3 because that's your slope. Slope is the number before the x. B, which is your y-intercept, because this is a slope-intercept form. So your b is 1. Now, what you're going to do is you're going to just graph it, but not put the line in. So I want to show it to you when we get there. Graphing the line should be the dots. Starts at a 1. And the equation of the line is really equal to 3 over 1. So because that's 3 over 1, that means you go up 3 over right 1, up 3 over right 1, and down 3 over to the right 1. See, it's still going this direction and this direction. So that's why it's up 3 over right 1. So now what you're going to do is you are going to decide this is a dotted or solid line. So in this case, because if you look at the symbol tells you it's going to be only a greater than symbol. Now since it doesn't have a little line underneath, that means I'm going to have a dotted line. So if you have an equal sign, it's a solid line. If you don't have an equal sign, it's going to be a dotted line. Okay, so I'm going to go over here. Now it's kind of nice when you have dotted line and then we already have dots put in. So you just kind of have to dot it and do not connect them. And don't forget to put your arrows on because it goes on forever. And your procedure second thing says, now pick a point. Choose an order pair on one side of the boundary line. Okay, so in this case, your trick to do this and to make your problem easier is to pick 0, 0. Very important to pick 0, 0 if your line does not go through 0, 0. Pick 0, 0 if the line does not go through 0, 0. And then you say, but Ms. Wisman, what happens if I pick 0, 0 and that's where the line goes through? Well, then we're going to pick another point, and when the time comes, I will show it to you. So in this case, since you look at the line does not go through 0, 0. I'm going to show you where does that go to. So in this case, I am going to pick 0, 0 right here. This is the point I'm picking. Okay, now I'm going to show my work on there. So if you pick 0, 0 and then you plug into the original equation, plug into original equation. So in this case, it's y is greater than 3x. I'm going to use that plus 1. And I'm going to plug in with a 0, 0. So that's going to be 0 greater than equal to 3. Oh, sorry, no equal to. 3 times 0 plus 1 is 0 0 bigger than 1. And in this case, you say no. It's not bigger. So instead of saying boundary line and whatever, the point you pick only gets shaded on that side when you have a yes. Since on that point I pick, it's no, I'm only shade the yes side. I only shade the yes side. So that point I pick, that side is no. The yes side is going to be over here. And that's all. Only shade the yes side. And that is how a graphing inequality gets done. Okay? All right, let's try another one. Example number 4. That's still in slope-intercept form. So you should know what is your slope. Pause, do the problem, and please check. Recap it for you. So first thing I did is I look at my equation. I say, okay, my AM is -1/3. My B is 2. So I graphed it. I put my dots in first. Then I decided because that is a greater than sign, no line underneath the greater than or less than symbol, so therefore it's going to be dotted. If there's a line underneath, it will be solid. So I graph my line, dotted line. Then I test it with a 0, 0 because 0, 0 is not on the line. I plug in 0, 0 to the original equation, and when I work it out, that's 0 greater than 2. Because 0 is not greater than 2, so that point I pick as 0, 0 location, it's no. So which side will be yes on the other side? So that is what the graph look like. Only shade the yes side. Only shade the yes side. Try number 5. Well, number 5 is a little bit different. Let's look at it. If you look at number 5, there's a couple ways of doing it. 1, you can do it x-intercept, y-intercept form. Or 2, you can do it by slope-intercept form. So if I do it by first way, x-intercept, example number 5. If you look at it, the form is not in slope-intercept form. It's in standard form. So there's 2 ways to graph this. 1, you don't have to change the form. You're going to use x-intercept and y-intercept form. 2, you can change it around and move and change it into slope-intercept form. And then you get worried about what you do with the sign. You move it, so you graph it like an equal sign. So let's talk about the first way. The first way is the x-intercept, y-intercept. And if you remember the first way, we have to draw our chart, and then if you put it in at y equals 0 and x equals 0. So if y equals 0, that's going to be x minus 2 times 0 equals, change the equal sign, 4. So that's going to be x equals 4. See how easy it is? Or you can just say, okay, the y equals 0. Well, that's 0. You can just look at the chart and say, oh, y equals 4. So it's up to you. Then the next one is x equals 0. So x equals 0, that means the first part is 0. Then you have minus 2 times y equals, changing into equal. Everything changes into equal. So you have negative 2y equals 4. And if you divide by negative 2, divide by negative 2, y equals negative 2. So your order pair is really 4, 0, and 0, negative 2. Okay? Now, some of you guys actually just realize, hey, if I just cover them, when y equals 0, that's gone. X equals 4. And when you cover them, y equals 0, x equals 0, solving for y, you can see it negative 2. Now, if you want to do that and then do it fast, so instead of showing the work in the little box, you are more than welcome to, because I can totally see that if you guys are in person, I would literally just cover it and then just graph it for you. So that's the first way, okay? So let's graph that. So you have 4, 0, 4 is on the x-axis. 4, 0 on the x-axis right here. And then the next point you have 0, negative 2, 0, negative 2, which is on the y-axis. Then what we're going to do is we are going to decide, is it greater than or equal to? Oh, look, it's equal to, it has an equal sign. So therefore, I have to draw a line. So when you draw a line, what you're going to have should look like this. There's your line. Okay, while you are drawing the line, you should eyeing it, say, oh wait, is 0, did they cross 0, 0? Well, guess not. They didn't cross 0, 0. So I'm going to pick 0, 0 and plug it into the original equation. So in this case, that's going to be 0 minus 2 times 0. Plug into here, plug into here. Is that greater or equal to 4? Is 0 less than or equal to 4? And the answer in this case is yes. So therefore, the answer you have here is yes. And I told you guys to shade the yes side. So you are shading the side the yes is located. And that is the problem can be done. Okay? That's one way. And the second way I'm going to show you is moving around to get slope-intercept form. So that I'm going to do it in green. Number 2 is going to be x minus 2y less than or equal to 4. And I'm going to just solve it like it's equal sign. So it's x minus 2y equals to 4. And then so because you need to get the y by itself, you got a minus x on both sides. And then you're going to divide by negative 2 all the way across. And that your equation is y equal to x over 2 plus 2. And then that's going to be slope is going to be 1 over 2 because that is like a 1 in front of it. And then your b is equal to 2. And then therefore you can double check. That's exactly what happened. Your 2 is right here. Oh, sorry, it should be negative 2. Negative 2 and negative 2. Okay, so when you have that, you can double. You divide by negative 2 all the way across, your new equation is going to be y equals to x over 2 minus 2. And x over 2 is really 1 over 2x minus 2. So your m is going to be 1 over 2, and your b equals going to be negative 2. So if you look at the problem, that's exactly what we have. You have the 2, negative 2 start right here, up 1 over 2, up 1 over 2, up 1 over 2. And that is another way you can graph the line. And go back and say, oh, less than or equal to, because there's an equal sign, therefore the line is solid. And that's example number 5. Let's take a look at example number 6. 2x plus 3y greater than or equal to 6. Now pause the video and check your answer. Answer for example 6. I just did it with the x-intercept and y-intercept way, which is right here. That's x-intercept, y-intercept. Then I choose 0, 0 to test, which is right here. And then when I test it, it says no. So therefore, I shade the yes side. The point I pick side is no. So the other side has to be yes. Number 7, there's a typo. It should be a x greater than c. So please mark that off. I will change your paper. So for me, even though it's c, for you guys, it's going to be x. So it's going to be x I'm gonna write that down, is greater than 2. Now, because we are on the plane, we got the coordinates, we got numbers with x and y on it, so they're order pairs. So we have to graph it in order pair form. So x is greater than 2 is 1. You should notice that's a dotted line. And then think about it. What are some of the numbers bigger than 2? Okay, so remember I say if the x is going to be like graphed like an equal sign. So it's really x equals 2. And I told you guys, it's like crossing the railroad tracks, crossing x-axis at 2. So crossing x-axis at 2 is going to be, this is your x, and that's your y. So crossing your x-axis at positive 2 is going to be right on here. Now what you're going to do is you're going to decide, is it dotted line or solid line? So if you look back, it does not have an equal sign. There's going to be a dotted line. And because it's dotted line, I'm just going to write it like this. And tell me, where is the line bigger than 2? Well, if it's bigger than 2, if you look at the equation, bigger than 2, it's got to be 3, 4, 5, 6, 7, 8. So therefore, it's this way. Because we are looking at the x-axis, because it's x greater than 2. This will be concluding our graphing linear inequality. Please let me know if you have any questions.